Welcome to this screencast where we'll talk about synchronizing volume snapshots for distributed workloads using the HPE CSI Driver for Kubernetes. My name is Michael Madsen. I'm a tech marketing engineer with Hewlett Packard Enterprise. Before we start, I just want to set the context a bit. I have a Kubernetes cluster with a WordPress application installed. And this WordPress application consists of one application server and a distributed database. I also have the HPE CSI Driver for Kubernetes installed, along with the necessary controllers to perform snapshotting. To be able to synchronize snapshots of distributed workloads, the user needs a logical construct to be able to group different volumes together and access those interfaces within Kubernetes itself. So in this example, I have the HPE CSI Driver for Kubernetes installed, and we can see here that we have a set of different API objects that we make available to the cluster administrator and the user. First, the cluster administrator needs to create something called a volume group class. The volume group class uses a HPE storage backend that has been configured on the cluster. Users will create something called volume groups. Volume groups are namespaced. And once the volume group has been created, a volume group content API object is created and the external volume group gets created. Initially, the external volume group is empty and the user will simply add members to the external volume group by annotating existing persistent volume claims. Volume group class parameters are unique per backend. So if we say, for example, that Nimble has one set of parameters and Primera and 3PAR has a different set of parameters. You will find these parameters on https://scod.hpedev.io. You will also find information on how to use these constructs under the using section, but I'm just going to show you here under container storage providers. You will find Nimble storage and you scroll down to volume group class parameters. Say, for example, you want to add array-based snapshots and replication to your volume group class. That is being done through this interface. And that's where you will reference the Nimble storage specific parameters that either has been predefined or defined by a storage administrator to allow replication to a downstream Nimble array or to HPE cloud volumes. Switching to my terminal, I'm going to create an initial volume group class. The volume group class refers to a secret that refers to a HPE storage backend that's already been provided by the cluster administrator. We're going to create that. Once the volume group class has been created, a user will then be able to create a volume group. And the volume group will simply refer to the volume group class name that we just created. We're going to kubectl that. The volume group provisioner will actually create an object on the HPE Nimble storage array. That is something called a volume collection. So let's log into the web UI and see what we can find. Under data protection, we will now see that we have an empty volume group created on the system. Back in my terminal, I will enumerate the PVCs that are available in my namespace. And we can see here that we have a number of different PVCs. And I want to be able to snapshot together the two MariaDB database volumes and also my NFS volume that serves the application server. Adding PVCs to our volume group is done by simply using the kubectl annotate command and giving it the custom annotation csi.hpe.com/volume-group equals and the volume group that you just created. Inspecting the volume group, you can now see that we have persistent volume claim names enumerated on the volume group. Switching back to the array UI, we'll now see that we have 3 volumes in the volume group. In the next steps, I'll show you how to create snapshot on this volume collection. Before we start creating snapshots, I just want to go over the API object model for snapshot group classes and snapshot groups. Again, imagine we have the HPE CSI Driver for Kubernetes installed, and these are the different objects that will become available to the cluster administrator and the end user: the snapshot group class, the snapshot group, and the snapshot group content. The snapshot group class is very similar to the volume group class. Give it a name, and you reference a HPE storage backend that already exists on a cluster. And again, the snapshot group class parameters are unique per backend. More responsibility is put on the user at this stage. To be able to create a snapshot group, the user needs to specify the volume group as source, and he also needs to understand what snapshot group classes are available on the cluster, and also volume snapshot classes. Volume snapshot classes are created with the CSI snapshot controller, and how to create volume snapshot classes is out of the scope for this tutorial, and more information can be found on SCOD on how to create volume snapshot classes and how to perform regular volume snapshots. Once a snapshot group is created, the snapshot group snapshotter will simply create an object called snapshot group content that will then reference external group snapshots that we created on our volume collection in the case we're using Nimble. We will also see in the demonstration later that we're using standard Kubernetes volume snapshots for this operation. Back in my terminal, I will create a snapshot group class. The snapshot group class simply references a secret that's already been defined on the cluster. I'm going to kubectl that. At this stage, users can then create something called a snapshot group by referencing a volume group as source, and also point out what snapshot group class name they want to use, and also which volume snapshot class name they want to create the Kubernetes snapshots from. I'm going to create a snapshot group. And by enumerating the volume snapshots, we'll now be able to see that each of the volumes or the persistent volume claims on the cluster each have a snapshot on their own. Switching back to the HPE Nimble Storage web UI, we can see that we already have a snapshot collection created. As users create more snapshots from Kubernetes, we'll be able to immediately see those snapshot collections on the volume collection in the HPE Nimble Storage UI. In other storage infrastructure frameworks, volume groups are usually referenced as consistency groups, and that means that the volumes within that group has referential integrity. In highly distributed application in a microservice architecture, it's crucial to keep data in sync. This was a very simple example with only 3 volumes, but say if you have a larger application with multiple services across multiple hosts, data might eventually skew if you have many volumes that you create snapshot in a sequence. When you create a snapshot group, that is not the case, as all the volumes are snapshotted at the exact same point in time on the backend storage system. We've already demonstrated in a previous screencast on how to use snapshot clones and perform restores of those snapshots. So please look for a screencast named Using Snapshots and Clones with the HPE CSI Driver for Kubernetes. If you'd like to know more, visit hpe.com/storage/containers. Until next time, take care.